Magni-X, we've been developing this technology for 2 decades, right? So it's been a long journey and lessons learned, and along the way, we've integrated in many different airframes, both in traditional CTOL, but also in vertical lift environments. Distributed electric propulsion gets a lot of airtime and press time. Taking what we've done and we've developed, putting it into a more compact, lighter weight package, very energy dense, high torque at a high RPM, to pair that with a Robinson 66 helicopter just makes a lot of sense.
All right, today at EAA 2025, Robinson Helicopter Company and Magni-X are excited to announce a expansion of our products in the form of an R66 that we're modifying for the full Magni-X electric powertrain that will let us provide our customers with a demonstration of what electric can do in an R66 form factor, and use that to inform the ultimate commercialization of an ER66 platform for the future. So we're excited to have customers come give us their feedback about a zero emissions R66, now the most popular turbine in commercial use. And we're excited that this will give customers what they've been asking for of solutions along the electrification ecosystem, and Magni-X is the best partner to do that with. So we're excited about it today.
So we're super excited at Magni-X to be partnered with Robinson Helicopter Company. We are going to be powering the ER66 with a full Magni-X powertrain. Magni-X has led the industry with 6 different airframes that we've flown electric, and we are going to be doing a more compact, more energy dense motor called the Helistorm motor at 6,000 RPM, 330 kilowatts. Combined with our Magni Drive, our PDU, and our Samson battery unit, with an industry-leading energy density of 300 watt-hours per kilogram to power the ER66.
Yeah, so Robinson has been in the center of the electric vertical takeoff and landing industry really since its beginning days. As we took on electrification, we have great customers who put a lot of emphasis on this in the early days in our ER66 predecessor, the ER44, and those programs helped to inform this work, and actually were powered by Magni-X motors. So the opportunity for us to take it to the next level and integrate actually a family of electrification architectures that enable this platform will be a pure electric that's powered by their battery systems and their motor powertrain. But there's alternatives that also feature Magni-X motors that are in the hydrogen fuel cell variant that United Therapeutics has publicly announced and shared. So all of those variations, plus hybrid variations that several defense customers have asked for, are all in various levels of development. But we're most excited, I think, for commercial applications. And I think today's announcement is focused on users like agriculture, tourism, private use, and training, all of which have expressed to us that their mission dynamics might allow for zero emissions in critical applications, sensitive applications, or missions where the additional advantage of electric can increase the utility of the aircraft, even if there is slightly less range or endurance. So we expect this to be a civil platform at its core, with maybe some defense applications along the road as well.
Magni-X, we've been developing this technology for 2 decades, right? So it's been a long journey and lessons learned, and along the way, we've integrated in many different airframes, both in traditional CTOL, but also in vertical lift environments. Certainly, I think distributed electric propulsion gets a lot of airtime and press time. Taking what we've done and we've developed, putting it into a more compact, lighter weight package, very energy dense, high torque, at a high RPM, to pair that with a Robinson 66 helicopter just makes a lot of sense. David talks very frequently about the 1,500 helicopters that exist today in the marketplace. We've spent a lot of time with customers coming to us saying, hey, we sure would love to electrify an R66. And so it's really the perfect application of decades worth of work coming together with a market opportunity with customers who are ready to adopt the technology today. So the 650 that you see here was traditionally designed for a CTOL application, although it's also powered vertical lift. It runs at a lower RPM. It's larger and it's heavier. And so really the application of the technology and what we've developed here is really about providing a super high torque, very lightweight engine at higher RPM. So the 650 is going to run at a low RPM, and the Helistorm's at a high RPM. It's roughly about half the power but much smaller packaging and much lighter weight. The Helistorm is, we were targeting 70 kilograms or less, and we're actually beating that estimate right now in our design.
We've got a lot of projects in work, but we've increased the team dramatically. So we're now almost 3 times the size we were when I started. And the skills and resource we brought in have been deliberately engaging people that came out of electric vehicle developments. So they have a lot of knowledge in this space. And on top of that, a lot of folks that came out of the eVTOL industry that were, I think, in their pursuit of electric vertical flight, they were unsatisfied by that industry and found ultimately that helicopters provide a really great platform that's safe, reliable, and highly efficient for all the various missions that eVTOLs are trying to achieve. And so I think you'll see over time that these are missions we deliberately build in a building block fashion so that the technologies that we use to support the ER66 are built off of things we've done with our ER44 work and with things we're doing on the R88 and R66 NXG programs. So there's a great deal of synergy amongst these programs to try to enable it to not be so much of an engineering workload for the staff, but they are very busy. There's no question about it.
Yeah, so we're super excited. Our engineering team's completely engaged on the Helistorm motor development and completing the development on our entire powertrain. So we will be ready to fly this full powertrain on an R66 during the year 2026.
So the key elements for us are this next year will be both the flight testing, getting to the formative first flight of this proof of concept aircraft. We'll also be in parallel engaging our customers. We have a lot of customers that fly missions that we think are supportable in an electric form. And so we'll engage them in a requirements development process for the ultimate commercialization of an ER66 of this architectural type. And then the expectation is later this decade, we'll have a certified motor. That's the work that magniX is working towards. And once that's certified, it'll allow us to implement that in a certified R66 variant down the road. So I think over time, we'll see how all of that evolves. I'm really keen to get an understanding from customers of seats and payload and speed. Those trades really inform the way we approach the battery architecture and how many battery modules we need and how quick for hot swapping and for the recharge cycles. So as we engage customers, we expect that feedback to inform the ultimate certified product later this decade. I think the challenge of an aircraft as big as the R88 is it will require, once again, a allotment of batteries and a large motor. Surely this effort will inform the entire future of electrified helicopters writ large. We're expecting the entire industry will be impacted by this over time, but the R88, as we unveiled, is a conventionally powered, turbine engine powered aircraft, but there could in the future be product in that class produced by Robinson that are driven by a Magni-X motor as well. And obviously we're standing next to a great one right behind us that certainly can power a much larger helicopter as well. But we need to work the speeds because almost all the turbine engines are in a very narrow speed range. And the more we get that amenable to the powertrains and the gearbox design and all that, the simpler the integration, the simpler the architectural changes will be. So we're excited about this as the sort of icebreaker to enable all of that down the road.